Okay, so today it's the 12th. It's it's actually 11:55. So it's but I still gotta get the problems for today. So I was gonna do I haven't done this one. This is the one I did yesterday where I think it's a little too fresh in my mind. Um I think I still know how to I definitely know how to do it. But But yeah, I don't want to do it just yet because I think it's a little too fresh in my mind. So I'll do this one. So I feel like for all these like dynamic programming type problems, um, there it's always down to like some kind of decision tree. So like I feel like that's why I it's easier for me to do it top down versus like bottom up. But yeah, I feel like. Uh, Maybe more like some more than others, but um like I feel like it's just way easier to do top down. But okay, let's go through this problem. I'm just gonna assume you've read it. So yeah. So for this, I want to have like a DP array where like this is like the current index I'm in like through the list. Or like let's say how many numbers have I passed? Yeah, how many numbers have I passed? Wait. This is this okay. So well, what I've solved it already, but what what my solution was I had like this array, well not array, this hash map where we had like our key was like the number, and then the value was like the like frequency, I guess. Frequency. And then I just went through I went through like the numbers like in a range from from 1 to the max num, right? And then for each number, um, we can either skip it. Well, we kind of have two choices. We can either skip or we can take, right? But yeah, if we take, then we can't take the neighboring things, the neighboring numbers of that. What I'm thinking now is just if we skip, how do we know that we skipped? Like let's say mm, yeah, let's say we skip 2. So we skip this. But then here, how do we know that we skipped this? Well, I guess yeah. I'm just thinking back to my solution because I remember my solution we just either took or we skipped. But how do we prevent from taking twice? Oh, I know. I remember. Oh yeah, I remember. Okay, yeah. So let's say with 2, 3, 4, like this case, I guess. So if we're here, if we take, we can't take here because we're right next to it. So we have to take from here. So from like our 1, which has a value of 0. So, but if we skip, we can get this value. We just bring this value over. So I'll run through a case. So in this we have 2 is 2, 3 is 3, and then 4 is 1. Right? So we're at 2. Well, we're going to the range, so I is 2. Right? And then I just have 1. Yeah, we have our counter, and then we will also have our DP. I have 0, 1, 2, 3, 4. Right? The max value we can get at 0 is 0 because, yeah, if we take with timesing everything, the amount of frequency of zeros times 0, so it's just 0. And we can't skip because if, I mean, we can skip, but we would have to take the value at -1, which is 0, so it's just 0. And then at 1, we can either take the number of 1s that we have, just taking, because if we take, we'll take the value at -1, and obviously the value at -1 is 0, like at the -1 index, because it's not even in bounds, so it's 0 plus the amount of 1s, which is 0, so 0 plus 0 is famously 0. And if we skip, we would just get the 0, so the max out of those two is 0 because they're the same. Okay, so at I equals 2, we have a choice of either taking from here, or we can take from here and add the amount of 2s that we have, which is 2 times 2 equals 4, right? So our score at 2 would be the max between 4 and 0, so that would be 4. Index 3, at index, yeah, at I equals 3, we're here. We can either take from here, or we can take from here. Remember, if we take this one, we can't add the amount of frequencies. So the max, it's between the max of 9, which is 3 times 3, right? And 4, because 4 is what we get if we skip. So obviously we're going to take 9 in that case. So this now becomes 9. In this case, with the 4, same thing. Are we going to take this or take this? Are we going to take this plus this, or are we just going to take 9? Obviously 9 is bigger than 8, so we'll pick 9 in this case. And then our value will be stored at the last index. Yes. Yeah, so that's it's like a DP using one dimension. I think I should start putting all the problems, not just like DP problems, but all the problems I can find in like a wheel and spinning it and then doing it that way, because I think when you know what you need to use, like that's already half of it like gone, you know? Like at that point, if you can't solve it, then you're just not at that level yet, I guess. But like half the challenge is just being able to like solve or like figure out what you need to use to solve it. So I mean, I just did this, so that that will accept, and it's all right. I don't really know how to make this better. I think maybe let's equal 1, and then times I. I think that's the optimization. So just adding it a bunch of times for no reason. Nope. Come on, give me a lucky test. Yeah, I don't know. Maybe this is max. Maybe if we don't do this and just run max sometimes. Yeah, maybe that was it. Okay, cool. The next problem. Yeah. Yeah, I'll be honest, I did not get this either, so maybe I'll just do this tomorrow. I do know how to do it, and it does make sense. Yeah. So, oh my god. Okay. Okay. So, I mean, I guess a good observation you can make is this problem is yeah, it's well what ChatGPT said, which I do it does make sense. So like if k equals 2, the only possibility is like AB. Like let's say we have a string of 4, it's just going to be one of these. So you just compare like the differences between if you chose this one versus this one, and then like that's your answer. But like if k is anything greater than 3, let's say A B B B A C C. Yeah. So it doesn't really matter, or like let me make it a bit like A C D B B A D, right? So like in this position, right? You know you need to change something, but it doesn't really matter if you change it to like B or D. Yeah, because even in the case that you chose D here, like the C is not gonna be next to like, well, when you move to the next iteration, this is fine, right? Like it doesn't really matter if you choose B or D. So all you have to do is when k equals 3, you can go to the list, right? And then whenever you find a character such that the character is the same as the previous character, you just have to change it to a character that isn't the one that is like upcoming, because then you would obviously have to change it, right? So I mean, yeah, that's it, to be honest, for that problem at least. I'll do that tomorrow because I kind of cheated and I looked at the answer beforehand. But yeah, I was going through like how you would do it, but like yeah, that's like just like a greedy solution, right? It's there's not that much like dynamic programming, is there? Like how would you do it? I feel like that's just being greedy. Like I don't know. I feel like though like being greedy and like I don't know, using dynamic programming, it feels very similar. I feel like it shouldn't be because I think I'm missing something. But yeah, I feel very similar. I think that's it for today. I was doing a lot of math problems today. I think I did a good bit. So I'll leave it for tomorrow. I'll do this one and this one, and I'll put some more problems in a wheel and then that's how we can choose which ones I do. Yeah, but that's it. See ya.